Bismillahirrahmanirrahim. Dear student, Assalamu alaikum. Here we have definition of Wronskian. Wronskian of the n functions y1, y2 up to yn is defined and denoted by the determinant. Here we have n functions. So Wronskian of these n function is denoted by this nth order determinant, and the Wronskian of these function is denoted by w of y1, y2, yn, which is equal to this determinant. And this determinant, the first row will have all the given function, and in the second row we will have its derivative. Similarly, in the third row we will have its second order derivative, and so on. So this represents the Wronskian of the given functions. Let y1, y2, yn be differentiable functions defined. We have these are functions differentiable on some interval I. Here we have interval I, and we have n functions. All these functions are differentiable in this interval. Then the functions y1 up to yn, these functions are called linearly independent on I if their Wronskian is not equal to 0. Whenever a Wronskian of the given function is not equal to 0, then the given functions are called linearly independent functions. Similarly, all the functions will be called linearly dependent on the interval if their Wronskian of the given function is equal to 0. Whenever a value of the Wronskian is 0, then the given function will be linearly dependent. If value of the Wronskian is non-zero, then the given function will be linearly independent. Now here we have three functions. Here we have this x is first function, this log x is second function, this is third function. If we put these three functions here, then here we will put x, here we will put log x, and here we will put x log x square. The root of x will be equal to 1, and the root of 1 will be equal to 0. Similarly, the root of log x will be equal to 1 over x. The root of 1 over x will be equal to minus 1 over x square. Here we will put x log x square. We will differentiate it by product rule. We will get value here. Then we will differentiate again, and we will get value of the second order derivative here. If we find value of that determinant, we will see that value of w will be not equal to 0. Hence, all these three functions will be linearly independent function. Here, Li means these functions are linearly independent. By linear independent, we mean that their Wronskian will not be equal to 0. Similarly, here we have two functions. If we put these two values here we will put e power x, here we will put e power minus x. The root of e power x will be e power x, the root of e power minus x will be minus e power minus x. If we find value of the second order determinant, we will see that value of the determinant will not be equal to 0. Hence, these two functions are called linearly independent function. For these three functions, value of w will be not equal to 0. Similarly, for these two functions, value of w will not be equal to 0. Hence, this set of functions and this set of functions, both the sets of functions are linearly independent functions. Thank you.